So we'll start in a minute. We just added a couple things to the bottom of the slide here. If you go to, so everything that I'm going to show you is online. Most of it is on GitHub. And the way that you can find those links is if you go to Twitter and search for Indie GSGEA, Getting Started Guide for Enterprise Architects. So that's where all this material are. The presentation isn't there, but it'll be there afterwards. For those that don't have the wireless password, it's System ID UK TAS, and then UK TAS 2019 for the password. You don't have to download everything and follow along. You can. But I'm going to walk through everything, and there's a lot of details that you'll want to look at after the session. So my recommendation would be to just kind of try and follow along, but if you're like me and your attention span is very short and you want to go do something else, then you can download the stuff. Also, I'm not too familiar with how the certificates are working this year, but if you go to belgem.io, that's where you'll learn how to get your certificate. I believe, if I heard correctly this morning, you have to attend like 3 sessions or 3 courses over these 2 days. So let's get started. My apologies, I know no Turkish and I only know a little bit of French. And I'm assuming that that is the same as this. And my name is Michael Herman. I'm an independent blockchain architect and developer. I dress like this every day. I'm actually a cattle rancher. I live in Alberta on a cattle ranch. And I also have 2 degrees in computer science, and I've been doing blockchain for a number of years now. I was invited to the first Turkey National Blockchain Workshop. It was Monday and Tuesday. I did a developer workshop on the Monday night. Apparently it was okay because they invited me back. I was expecting, 10 or 12 people, nice group, and we had 240 people show up. And most of the people got through the labs. I try to make sure that everybody feels successful, and that's the same, my same goal today. How many people saw Phil's demonstration or part of Phil's demonstration this morning of the Connect.me app? Okay. So I'm not sure of the origin of it, but this, what I call the Alice buys a car user story, is the same user story that's used almost for all demos for digital identity. So that's embedded in, that user story, Alice buys a car, is embedded in the demo that Phil did this morning. It's also the main idea, the main stream of what I'm going to be talking about today as I try to explain digital identities and credentials. My demo will be much simpler. It's really a long Python script that talks to the Hyperledger Indy SDK, and it writes stuff to the ledger and it writes stuff to wallets. But about 1.5 years ago, when I was trying to understand digital identity and trying to understand Hyperledger Indy and how does it work, I started with an early version of that script, but it would just dump out tons and tons of stuff to the screen, and it was difficult to understand what was happening. So I'm showing you a new version that I created over the last 1.5 years, where every step is numbered. So you can look in the code, see that it's number 111. You can see in the output it's number 111. I've also created interaction diagrams and communication diagrams with the same numbering. And then there is an updated version of this document called the Getting Started Guide that also uses those same things. So, correlation is a bad word when it comes to digital identity, but we have a highly correlated demo. The Python script is numbered, the output is numbered, the communication diagrams are numbered, and you can see those all together in the guide. And so when I say you're probably better off just to follow along today, it's because all of that content, all of that material works well together, and you can study it on your own. So it's a Python script. It's really just intended for education and training, and education and training in terms of understanding the principles of digital identity and credentials. It's not like you'd use it for any production code. I think what you want to do is go to Mike Lauder's talk, which is right after mine, like 30-minute break after mine. And then Mike, if you think of mine as the appetizer, you get all the basics on one plate, then Mike Lauder is going to take you much deeper into verified credentials and some real applications that some of our colleagues in the digital identity community have created. So we didn't intend it to be like a 1, 2, 3 punch with Phil kind of introducing the story this morning. I'm going to take you through the principles, and then Mike Lauder is going to finish it up at the end of the afternoon. So let's kind of get started with that. I'm sometimes guilty of having a few too many slides, but I like to make this. Oh, what's happening here? There we go. So I do live on a cattle ranch, and I own cows, and I have cows with calves, and in another couple of weeks we'll be taking the calves to market. So one of the things that's interesting is it's a great digital identity laboratory, because we have several ways that we identify the cows and the calves. You can't really see, oh, in this picture you can. They wear RFID tags in their ear so that we can electronically read the identity. We have brands that go in a particular location on the animal. So mine is R/C, and it goes on the left rib. When I'm talking to a neighbor who knows my cows, we can talk about, you know, the white face Hereford calf off of this particular cow, and if he's familiar with my herd, he would know. So the idea that identity kind of has a context or a scope, depending on who you're talking to. And that's what the Alberta prairie looks like. It's flat. It's not like what I've seen of Turkey so far. Although you seem to have a dry weather, at least on the ground, similar to ours. Some days I feel like this. I just like this picture, so I thought I'd put it up. But this is what a blockchain architect looks like on a good day. I mentioned that I was invited in was April 2018, and I really enjoyed my time, and I'm privileged to be invited back. I guess I'm going to have to stay closer to the laptop. This is one slide that I used from then, and it kind of is the beginning of a story that I'm going to talk about a little bit more tomorrow. I'm doing the second keynote presentation as well. But if you're familiar with, you know, Ethereum tokens and how you create tokens, either the ERC20, you know, smart contract template, or on the Neo blockchain, it's called NEP5. There's really one key method there called transfer, and it's for transferring value from one address to another address to another address to another address. And so I always questioned where was the real business value in this kind of scenario. And I said, what if instead we could take a business process, one where we submit a requisition like a timesheet or an expense report, actually submit it to the smart contract, have it approved and rejected. Maybe if the amount of the requisition was below a certain number, it could be automatically approved by the smart contract, or maybe it was worth a little bit more. A clerk could do it, or maybe a little bit more, and a manager might actually have to approve it. And so I've been kind of playing with this idea for the last year or so. But the idea that there's smart data that's wrapped in a smart contract, and instead of just having transfer as our operation or method, we have the operations like create and submit, approve, reject, and route, and finally pay, that we actually use the cryptocurrency in a proper business process. Tomorrow what I'm going to be talking about is, my topic is the trusted digital web. To describe where I am in that thinking about coupling decentralized currency with decentralized business processes that actually run on the blockchain, and of course with decentralized digital identity, which is what we're talking about today. But it's interesting once you see digital identity being used in a context, once you see digital identity being used in a real business context, a real business process. Phil, at the end of his talk today, alluded to the fact that, workflows on the internet, trusted workflows, decentralized workflows, are enabled by digital identity. Digital identity just in and of itself is not that useful until it's applied and used in a context. So I'll talk more about this in the morning. So the training goals for today, so I'm targeting architects and developers, and I love talking to architects and developers. Give you all the basics around digital identity and prepare you for Mike's talk this afternoon. Mike and I hadn't really planned anything advanced. We met last night, and it turns out that my talk and his are in the right order. I like to make software easy to understand, but more than make it easy to understand, make it easy for you to explain it to somebody else. I think that's a higher goal, a higher challenge, and we'll see what we can do. The level of training, it's about awareness and basic knowledge. I'm just going to get you off the ground so that you're cognizant, so you can have intelligent conversations about user identity. And as I said before, the user story that we're dealing with is the one about Alice buys a car. And I'm going to try and explain that in a way that makes sense to enterprise software developers. And by that, I mean we're going to start at the beginning with a user story and look at the use cases and build some business process diagrams and gradually work our way into how do we make this a digital identity and digital credential based solution. So it should start at a place where you're familiar, and we'll take you all the way through. The resources, as I said, if you go to Twitter and look for, again, Indie Getting Started Guide EA, I think I've got 4 or 5 links up there. You want to look for the setup document, which tells you how to create the Docker environment if you want to run this live now or when you get home tonight, or you should probably spend all weekend on this if I were you, you know what I mean? And then there's another document, which is the Getting Started Guide itself, that will walk you through. We've also got some chairs on the stage we can use too if people want. If you need extra chairs, we have some here. And then there's also some articles that I've written. When I think about blockchain, I think of it as a technology from an architectural and from a developer perspective, but I also think a lot about adoption, technology adoption, life cycles, and those sorts of things. You'll find some articles there related to that. So we're going to do some stuff around core concepts before we get into the actual walkthrough. Those would be the 2 main pieces. So we're going to make sure this concept of a subject is clear to people. And most of the explanations I've seen around what a digital identity is and what an identifier is, here's a chair, come up and get a chair. Haven't been that clear, or they've been kind of abstract. And so I'll hope to clear that up. And then we'll talk about digital identities and how those relate. So what's a subject? So when we're talking about a digital identity has to relate to something. And so that's something we call a subject. So if we think of a unique subject, it's any unique or specific non-fungible object in the physical or digital universe. So it's the real thing that we're talking about. It's the person, or it might be the car, or a laptop, or a business document, a purchase order, an invoice. That's the unique subject. That's the real thing. And then we have sometimes called a digital twin, a digital analog. That's the digital subject. And when you read most about digital identity and digital identifiers, they're talking about subject and they're referring to the digital subject. I find it's just useful to clarify these, at least until people become more familiar. So a digital subject is the unique digital representation of a unique subject. And in the case of a person, you may have more than one persona. There might be Michael Herman, the business architect, there might be Michael Herman, the blockchain architect, there might be Michael Herman, the father, etc. So we'll go through some diagrams that will help visualize these. So at the top here we have the real or the virtual subject, for example, myself. There's different personas, different roles I have, the different ways that I appear to other people. Personas are fairly common in, conventional software development. And then you have the digital subject, the digital analog of that persona. And the idea is that people will have more than one digital identifier. There's many scenarios where you'll have more than one digital identifier. Phil talked a little bit about that this morning. Even just pairwise communication will each have a unique pair of digital identifiers, or DIDs, so that we can have a private conversation. Nobody else won't necessarily know our unique identifiers. But again, each of our different roles, even today, like I have a relationship with my bank, I have a different identifier for the bank in terms of my banking card. I have a different relationship between myself and the cell phone company and everybody that uses my cell phone, which is my cell phone number. So you're going to have many digital subjects that relate to yourself, and then hopefully some of those will be verifiable. In this particular example, technically I'm a rancher in Alberta, but I had to be officially a rancher in Alberta to be able to get a discount on the fuel, on the gasoline that I buy. And so in Alberta it's called a farm fuel tax exemption certificate, just to pick an example. So subjects can be, in the end it always has to relate to real people or to real things typically. It could be a more virtual thing like a virtual machine, but it has to be a something. Digital identifiers. So if we have a digital subject, then we can assign an identifier to it. And you'll see interchangeably I use the term DID and universal DID. DIDs are typically used to refer to a certain category of digital identifiers. I use universal identifiers to refer to anything that you want to name or identify with a digital identifier. And so here we see examples of what DIDs look like. They always start with DID colon, and then they have something called a method, which is like a namespace. And the DID method can have more than one part, and then depending on the DID method, there's some sort of unique identifier that's at the end. And so that's very method specific. So this morning, Phil was representing the Sovereign Foundation, which operates the Sovereign Network. The Sovereign Network has a sovereign governance framework, and they have a special format for theirs, and it's DID colon SOV, and then whatever their unique identifiers are. Thanks, Orhan. I thought the bad people had to sit at the front. So a DID starts with the phrase DID. Followed by one or more DID methods, like the second example, and then followed by the method-specific identifier. So we've got subjects that have a corresponding digital subject, and then we have digital subjects we can assign identifiers to them. We haven't talked about identities yet. We've just said that subjects can have identifiers. A number. So what's an identity? A digital identity is a set of claims, and I'll talk about claims in a minute, a set of claims made by one digital subject about itself or about another digital subject. And there's a paper that was referred to this morning called The Laws of Identity. Kim Cameron, I think, is the author from Microsoft. He provided some of the earliest and what I find the clearest and simplest definitions, so I borrowed that from his. It's a set of claims made by one digital subject about itself or another digital subject. A digital identity is associated with one or more DIDs. So to turn this around, if we start with digital subjects, and then we've got digital identities associated with the digital identity, We started with subjects, we had identifiers, and then associated with identifiers, we have identities. And an identity is a set of claims. A claim is any data that's associated with that digital identity by way of a DID. So if this is my subject, this would be my real physical subject. If I created a digital analog of this, then it can be given an identifier, and then the identity is a set of name-value pairs, a set of claims related to that identifier that relates it to the subject. Preferably, the claim data and the relationship to the digital identity are represented or persisted in a manner that is immutable, auditable, verifiable, permanent, and historized. So this is where the blockchain comes in. We want to be able to store those relationships between the claim data, the relationship between the claim data and the digital identity. The reason why we don't want to put the actual claim data on the blockchain is mostly due to GDPR. We've got to be able to erase, we have to be able to forget people. So you can store the digital identity, that character string, but you need to be able to erase the claim data. Another name for this set of claims is called a credential. And this morning we heard about verified credentials, so we'll talk about a little bit more about those. But just a set of claims, a set of name-value pairs is a credential, and then if you have a collection of credentials, it's sometimes called a profile. Those are probably the most important, simplest terms. Those are the terms that will help you when Mike Lauder speaks with you later today. So here's the picture. So we've got digital identifiers here, and they can be associated with a credential, or there's something called a DID document, which is just a different kind, a special kind of credential. Those credentials are realized from some place where you store the claims, the individual claims, and associated with those individual claims would be the identifier for the credential, and in turn the credential would have the identifier for the subject, which I think is on the next slide. There is this concept of issuer, like somebody either in a permissioned or permissionless blockchain needs to be able to create those identifiers and in turn create the credentials. They need to have permissions to put them on the blockchain. I see people taking pictures. I'm going to give you these exact slides. I'll give you the original PPT file if that saves you a little bit of trouble. So what are verifiable digital identities? Well, verified digital identities don't just have data associated with them, but they have this concept of some sort of immutable proof, some sort of signature that's persisted on the blockchain. It's kind of interesting because if we go back 18 months when I was talking about smart contracts and blockchain, it was just about smart contracts and blockchain that seemed to be the most important thing. Identity has really evolved to be the most important thing, and we hardly talk about the blockchain and smart contracts anymore. Not that they haven't gone away, but the idea of representing what I call every little thing, hashtag ELT, using a digital identity and being able to process those through a workflow, running on a workflow engine. That workflow engine may run in a smart contract, or it may run someplace else, but this concept of credentials being collections of claims, which are just name-value pairs, and that you do some sort of digital signature around that and persist that as an immutable proof is sort of the key and core to what we're talking about. This kind of combines all the pictures. So we started off with real subjects, real people or physical things. The idea that there may be different views or projections of those things, we call those personas. There's a digital twin or digital analog of that that's given an identifier. and it's associated with the identifier that we connect the credential, we connect the information. And you might have many different kinds of credentials, right? Just like you might have many persona, you might have a different credential, likely have a different credential for each persona, but even for a given persona, you might have a different credential for each different person or company or party that you interact with. Not everybody's entitled to the information that they think they should have, right? So the idea of minimal disclosure. And the fact that there's this some sort of entity called an issuer that has the issuer role that's responsible for somehow adjudicating how those get connected to the blockchain. Any questions so far? Yeah.
Something extendable. I mean,
okay.
I couldn't understand the difference or the correlation between the did itself, the
right. So
verifiable.
the identifier is always just a character string. The credentials, think of them typically as like JSON objects, so they can be arbitrarily complex. And in the Hyperledger Indy platform, you actually have schema definitions to describe what elements can be part of your credential, what your JSON should look like.
Yes.
Does that answer the question?
Not exactly.
If the answer is more simple, credentials can be arbitrarily complex. So it's not just simple name equals value. It could be name equals a value, but that value could also be complex as well. So I think of the more complicated credentials might be like a purchase order that has many different addresses and many different parts and line items to it. Is that a good start?
Yeah.
Okay. This diagram here actually goes back. I can't walk too far away from my laptop, I guess. I was actually having lunch with a friend in Toronto, Mark Annabali, and we started sketching out. We didn't know anything about digital identity then, but the spoon is the subject. We said there's this concept that there's a person or the central identity. And then, when we ordered food, they give you one of these things and it would beep when your food is ready. So that, of course, was the digital twin. That's the digital subject. And then I think these are business cards. I'm not sure what they were, but those represent the different digital subjects that are connected. And then these were different apps. And I forget what's happening here, but there was another entity on this side working back and forth. But I just want to give Mark credit, and this was kind of a famous picture between he and I. Okay, so that's the first part. Those are kind of the principles. Now we're going to get into how does this stuff actually work? We're going to look at some software. I've been kind of using two words interchangeably, Indy and Aries. So up until the beginning of the summer, it used to be called Hyperledger Indy. That was the platform, the primary platform, the prevailing platform for doing most digital identity work. And over the summer, there was a refactoring of the projects. And I think it's right now, Mike Lauder is talking about those three individual projects. The main one is called Aries now, and that's the agent, the digital identity agent. There's the crypto one, and its name escapes me at the moment, and then there's a third one which is around communications. And so normally, and this is what Phil was showing tomorrow or this morning, and this is what Mike's going to be showing this afternoon, is you actually have two agent processes that are talking back and forth over a DID protocol, and the DID protocols exchanging credentials and using DIDs to identify each endpoint stuff. This is not what we're using, but this is what Mike will show you later. What I'm going to show you is, again, it's just a long sequential script that talks into the SDK. And so it's really just one process, right? It's one script running in Python. But it's going to physically create through the API these different wallets, one for the sovereign steward, the top level identity that has the rights to create new credentials. And then we're going to create 5 new wallets. And if you're a little bit familiar with the Alice buys a car scenario, which you'll become very familiar with in a moment, those correspond to the 5 main actors that are part of this. And then from time to time, in addition to writing things into the wallet, it's going to need to be able to persist things to the Indie ledger. And things like those digital identifiers, they go into a special type of transaction called a NIM, an NYM, and then the other attributes, the other types of claim data go in as attributes. There's other transactions for schema and schema definitions, etc. You don't have to know too much of that detail, but when you look at the code, there's times when you're doing bidirectional communication, one-to-one communication between 2 parties, between 2 agents. That's, of course, simulated because this is just a sequential list of calls. And there's times when you're saying, this is my DID. I want to put it on the ledger. And the reason I want to put it on the ledger, because if I'm at one point in here, if I'm the government, or let's say I'm Alice, I want to publish my DID here for my interactions with the thrift bank. And when I send it to the thrift bank wants a way, an independent way of checking that this is really my DID. And the only way that the thrift bank, Alice can send a DID here, but the only way that the thrift bank can verify that this is a valid DID, that it's actually Alice's, is it goes down and tries to find an IM transaction that matches. And it'll look at the things like the keys, the public keys that are associated with what Alice is claiming. And once the thrift bank has been able to do that, then the thrift bank will trust that communication. So anything that's kind of out of band, anything, this is almost like in hardware, like in a personal computer, there's a bus that information flows, back and forth on. You can almost think of the ledger as being like that bus that you can just dip down onto and check to see primarily if a DID is a valid DID. Credentials are also stored here. So for example, the sovereign steward can create credential definitions, claim definitions, and put them there. And so these are going back to this lady's question, that's where these trusted definitions of what these credentials look like. This is what the schema for these JSON objects look like. They're there, they're signed by the sovereign steward. Any of these parties, when they receive a credential or credential definition, they're able to validate that it's an authentic one because it's verifiably stored on the blockchain, on the ledger. And in fact, it's not just verifying that it's there, you can actually read the whole thing back. So that's kind of the software scenario, and I'm just highlighting that this is really just, again, a sequential list of calls where the one script is trying to play all of these different roles one step at a time. And so that's fundamentally different from having 2 processes going back and forth or 5 processes going back and forth. I just want to be clear about that. Okay, so this is the Getting Started guide. This is sort of that, whatever it is, 4th or 5th artifact that I talked about. And as we're going to scroll through that, and you'll see the development of the application from a business analyst perspective, and then we'll get into the design of the solution, which again is just a Python script. But I tried to simulate the thought processes that you'd have to go through from an architecture, both an architect's perspective and a developer's perspective. Again, if you go to Twitter, hashtag Indie GSGEA, it's probably the second last or the last link there, because I think it returns them in reverse order. There's also a setup guide that talks about how to create the Docker environment that this Python script works on. So I'm used to work for Microsoft for several years, and so I'm very much a Windows person. I know probably most of you aren't, although I know in Turkey, C# and .NET Core are quite popular, because that's what we did the previous workshop in. But if you scroll down in that guide, again, you don't have to look at the URL, but if you go to the hashtag, you'll find the setup guide, and then you can scroll down. These are the exact steps I ran last night, so that they've been tested. I know they work. Well, actually, no, they didn't work last night, but I can tell you they worked this morning. So you'll want to run the steps in the setup guide. We'll talk a little bit about those steps in a minute, and then you can go back and do the walkthrough. So the user story has these 4 use cases. So now we're going to get into the meat of this. This is sort of the driving inputs into the scenario, the one that we're going to implement running on Hyperledger Indy, the same one that you saw Phil work with this morning. So Alice wants to buy a car, and I do a little bit of embellishment. I exaggerate things a little bit. So in this case, she's buying a red Lamborghini. And she wants to buy it from Carter's Cars. And so, you know, as a business analyst, I look at it and I say, well, Alice must be an actor. The bright red Lamborghini must be important because it's a bright red Lamborghini, and Carter's Cars. To purchase the car from Carter's Car, Alice needs to take out a loan from the thrift bank for the entire purchase price. So maybe it's not 100% realistic, but that's the idea. So here we learn that, you know, Carter's Car is involved again, and Alice is involved again, and we have this new actor called Thrift Bank, and we have something, some sort of loan, some sort of business document and business process that needs to be enacted. To get the loan, Alice needs to find a job. She wants a Lamborghini, but she doesn't have a job. So maybe we're not as realistic as I hoped. And she needs to present a job certificate from her employer to the bank, verifying her employment, salary level, and length of service. So she needs to get a loan, she has to find a job, and then she has to get verification to give to the bank. Verifying her employment, salary level, and length of service. So this sounds like a business document, this sounds like a credential. This is an example of a credential that would have multiple parts, right? That she's employed, perhaps with her job title, when she started work, her length of service, and her salary level. Those would be all elements in that particular credential. To find a job, she applies at Acme Corporation, and to apply for that job, she needs a verifiable copy of her transcript from Faber College. She needs a credential to show that she graduated from there and that she has the appropriate, you know, courses and credits. In this case, a bachelor's degree. So far, Alice doesn't have any of those, but she did graduate and she has her bachelor's degree, so we're probably going to start there and work back through the process. So if we think of the workflow, we're not even into digital identity yet, we're not into blockchain or Hyperledger or anything. From a workflow perspective, we need to identify the actors, the business roles, the processes and sub-processes, and the state or the artifacts that are part of this process, the business documents that represent a credential. So when you look in this Getting Started guide, I worked through it kind of layer by layer based on those use cases, but this is kind of the combined example. So we start at the top where she wants to buy a car. She needs a car loan. To get a car loan, she needs financing. To do the financing, she needs a job certificate. She needs a proof of employment. She has to go through a recruiting and hiring process, and to do that, she needs her transcript, which needs to be issued by Faber College. And so Alice is the actor on one side of each one of these processes. There's Carter's Cars. Well, I'm not sure the Lamborghini's an actor yet, but the Thrift Bank, Acme Corp, and Faber College. So here, Acme has two roles, that of the employer that's going to generate the job certificate, but she has to get past the recruiting function initially using her transcript, passing the job interview so that she can get the employment record. So this is just kind of classical business analysis, classical data processing. This is an eye chart. You can look at it in more detail online. This is starting to map Thrift Bank, Acme, Faber, and the government into different roles, different functional roles when it comes to digital identity. So one of the things we have, we call trust anchor role, which is part of the issuer role, which is part of a sovereign entity role, and it's also an identity role. There's something called the Sovereign Glossary, Sovereign Glossary version 2 that defines all of these terms. When I started to understand these and the hierarchy, I built something called the Sovereign Architecture Reference Models, Sovereign ARM. I think I have a link. I think I have a link for that on Twitter. But it'll help you understand all the relationships and all the definitions between these. It's not only the words, but the actual definitions, the glossary entries for each one of those. But what we're really starting to do here is starting to adapt the simple business process description into something that's more amenable to digital identity and running on the blockchain. I think he has a microphone here. Yes, so in what I call the walkthrough, it's in there. All of these images are in that walkthrough document. So it's the last or the second last link that's on Twitter. And we're going to go into that. I'm just kind of trying to give a bit of an overview. And I realize some of these are hard to see. No. So when we look at kind of that center part of the detailed business process diagram, we find that there's sort of four main flows here. If we ignore setup and we ignore the cleanup, we have to kind of start in reverse. We have to get the transcript issued. We have to go through the recruiting and hiring process. We have to generate the proof of employment, and we have to get the car financing. And once we have that, we can proceed with the purchase. This is the same diagram that we saw before, but now you get a feeling that we're going to be interacting that business process up here in the Python script, and it's going to execute methods that are part of the SDK, which isn't shown on here, to use to pretend at different points in the script that it's taking on the roles of those different actors, talking to the wallet and talking to the blockchain. Okay, another eye chart. You'll find it in the Getting Started guide. This is just going a little bit further. This part here is all the same, but we had to add something called did groups. When we're setting up communication between two pairs of endpoints, we have to create did groups, and groups are described again in the sovereign glossary. Here's what the sovereign architecture reference model looks like. Again, the link is there, and it allows you to interactively navigate through all of these definitions, all the relationships between the definitions. For example, when you click on one, for example, verifiable entity or sovereign entity, you get the definition displayed here on the left. If you're wondering what I use for most of these diagrams, it's a language called Archimate, which is kind of favored language used by enterprise architects, and I use a open source tool called Archie for creating these diagrams.
For creating this document, you use which tool?
So let me just back up, because I could give you an easy answer, but I might. So these diagrams in general are used a language called Archimate and a tool called Archie, A-R-C-H-I. And I think to answer your question, Archie will publish this interactive browser directly out of the tool, like in 3 clicks. Yeah, it's quite useful. Okay, so let's actually go through the walkthrough, and we'll actually get into the document, and you'll see some of those in higher resolution. So in my introduction, I talked about these different artifacts and how that they're strongly correlated, and that's what makes this a good learning or a good training example. So there was the original Getting Started Python file that just spewed out hundreds and hundreds of lines. But if you're interested in a particular, how did he or she create this kind of credential, and how did he or she write into this wallet, it was hard to match up what was coming out as output with what was in the script. So then I created the numbered script, and then you got the numbered trace file, then I created the communication diagrams, and then there's the guide that we're going to look at. So when you go to do this on your own, there's 3 or 4 steps. And this first part I call setup, and there's 2 screens. This is described in the setup readme.md file. And I've tried to make it absolutely foolproof. I don't want to say it like that, because if it doesn't work, you're going to go, oh yeah, you thought I was a fool. But right down to making the directories, so it assumes that it's going to create a drive called Indie. Indie on your C drive. It's going to remove everything that's there, and then it's going to go up and clone the repo, the Indie dev repo, and it's going to pause. So when it pauses, you'll have to remember why. And then it goes into that directory after it's cloned the repo down onto your hard drive. It's going to go into that, and it's going to run these 2 Docker commands. So these are going to build 2 images, 2 Docker images, Indie pool and Indie dev. If you don't know anything about Docker, you just run these commands, and you don't have to know anything about Docker. The only thing I know about Docker is that if I type these commands in, they work. This command, Docker images, will list all the images, all the think of them like virtual machines that are in your Docker environment. And at this point, you've downloaded everything, you've built the images, and they're installed into Docker. In fact, this last one, I'll just leave it at that. And then the second step is, once you've created the images, you need to run them. And so this command, which again is in the readme.md, you run those 2 images. This one is the pool. This is essentially the blockchain. And then this is kind of a host environment where you're going to run your Python script. There's some Windows stuff here, syntax that's special for Windows, different from if you're running Docker under Linux. But I explained that in the README. And so when this second Docker run command finishes, you're going to get a command line console. You're going to get a Linux command line console that you can then run Python from and run the script. But my message is these are very mechanical steps, and they'll work because I just ran them. So when you get that shell script there, that shell prompt, the Linux shell prompt, you're going to go to the root. You're going to go to the Indie dev folder, and that's actually the folder that you created here. That funny stuff that was at the end, that's just mounting your local C drive, a folder in your local C drive, into your Linux environment, Linux Docker environment. Then the cool thing about that then is you can use Visual Studio Code, for example, to edit the files that are on your C drive, and they're automatically going to be, reflected or available in your Linux image. So when we CD into that, we're actually going into a folder that's shared off of our hard drive. We're going to go into the Python directory. I'm not sure what happened to my laser pointer, but go into the Python directory, type in ls to see what's there, and you're going to see a bunch of Python scripts. So this is the original Python script that's unnumbered. This is the one that is numbered, and so you want to type Python 3 getting started -number.py. And it looks a little bit like this, and you can see this is where I've added a bunch of logging information in this hierarchical numbering scheme. So for example, this says getting the trust anchor credentials for the government using the Veronym, method. And so here we see get Veronym, and we're using the credentials of the sovereign steward to get the government NIM, or the government trust credentials. And this is just repetitious like this all the way through. And then the nice thing about it is that you get this kind of output. So you can see where we're getting, trust anchor credentials. Again, for that was that actual line we looked at. And here we can see all the steps that were involved in that. It was very tedious to create this, but it was quite a learning exercise. And so it's going to be a little bit tedious to read it, because you almost have to have this trace output, and you have to have the source code, or find a piece in the trace output that's of interest to you. There is an actual copy of the trace output in the GitHub repo, so you don't have to go through and create all the Docker images. But at least for the way that I like to think, the idea of seeing the one-to-one correspondence between the script and the output and the effects it was having seemed to work quite well. And it'll just run through to completion. There's 5 major sections. 6 is just doing some cleanup. So we're going to now jump over into GitHub. And let's go there for a moment. Can I change over? Okay, so this is the actual guide that I was talking about, and it goes through pretty much exactly like I was describing it. So here's the business analysis section, where we look at that first scenario or use case of Alice buying the car, and then we find out that she needs a loan, etc. And we end up building up to that one large eye chart that we saw before. And so you can scroll through that and see those details there. And then we find a list of all the credentials by analyzing what we saw above. We begin sort of the business process analysis. Remember, we had these high-level processes here, and then we got into each one of those. And so the rest of the guide tends to be very detailed descriptions of each one of these boxes. This is a sort of a breakdown, if you will, of whatever it is, the 1,200 lines or whatever of Python that's there, into different pieces of functionality. So if you want to find out, for example, how to set up a credential, you could just jump, to 2.30 or 2.31. Within the output and within the script to see how that's done. Again, you're programming against the SDK. These days you're probably not going to do that unless you're building a lower level framework. Mike will be talking about some higher level frameworks like Street Cred that make it much easier than programming against the low level SDK. But it's really important, I think, to go through the pain of this once, so that you understand some of these principles and how and when things need to be written to the ledger, and when things are just communicated with each other. This is the first entity diagram that we looked at, actor diagram, that was hard to read. If we go down a little bit further, Oh, that's just showing how we start at the beginning. We just have the Python script at the top, and we have the ledger. But then as we execute it, then that's when the different wallets are programmably being created and the ledger's being updated. There's the more detailed data model, if you will, showing the groups and the different additional members of the sovereign framework that are needed. And then we're going to get into the super detailed part here. So this now goes piece by piece through this code, explaining the code and what it's trying to do. And the value add that I created here was showing for each one of those output statements what it was trying to do in one line and showing the relationship. So if we look at this one, this is about getting the trust anchor credentials for the government. So we're onboarding the government. We're creating the government digital identity, and we're putting its DIDs, et cetera, down onto the blockchain. We're also creating its wallets and storing things into the wallets. So I could change the zoom here to show you, but sorry, I'm going to probably mess the guy up here a little bit. These different tasks within the detailed flow show when and where the wallet's being accessed. For example, in 1.1.12, create and store the government DID. Well, it's storing it in the wallet. We're also seeing places where stuff is being written onto the journal. So for example, at some point we need to send the government ID to the ledger so that it can be used later on in the business process. So that's what this line is here. Each pair in the communications has a DID associated with that communications pairing. So in 1.1.11, we see that we're sending the DID for that pairwise communication down onto the ledger as well. So a combination of reading the text and following these diagrams will give you a good visualization of what's happening at the level of individual ledger transactions and individual wallet transactions. These diagrams get really small. Let me see if I can improve that. I'm just going to kind of show a few of these so that you get the sense for it. Well, that's a little bit better, so that you can get the style of it. Download. Yeah. So the previous diagram we looked at is more of a business process workflow view, and this is really kind of an interaction diagram. It's showing all the same pieces. Remember, we had 1.11 and 1.12. So 1.11 was sending the NIM and the verification key. This is showing the actual exchange. So here's a connection request going from the sovereign steward to the government. So this is about setting up the government as an entity and establishing its digital identity. So 1.1.3, you go to 1.1.4, creates a wallet, and then it creates a government sovereign steward DID. And then 1.1.6, you have to kind of walk through this and figure out the different steps. So 1.1.6 was to get that DID off the blockchain because it was written there in a previous step back here. It's not quite as complicated as it looks. It's tedious. There's lots of details there, and that's why some of these higher level frameworks like Street Cred were created. Because as you go through and look, you know, the sovereign steward working to create the government, well, the sovereign steward also has to create the identity for the thrift bank and for Faber College, and it's all very repetitious, and so those are the things that helps with. So we go down, so here, going down here, there's Faber College. creating the credentials for it. So we step through all of those. And again, it does get fairly repetitious. If we go down a little bit further, this is showing the storing a credential and retrieving the credential. We're not going to go through each and every one of these, but it'll give you a pretty good idea of how that works. So here, we create the certificate schema, so that's creating the in-memory version of it, the transcript schema. We're letting the government be the issuer or the authority over those schema. And then part of the connection logic is to send those schema to the ledger as a schema transaction and send the transcript schema to the ledger later on. So the government here is the issuing body. If we looked a little farther ahead, when Faber College needs to issue the transcript, what it's going to do is get the transcript schema back so that it knows what the fields are and what the names are. And it'll create an appropriate credential document and use that as part of the exchange between the two parties, between Faber College. Faber College will use that as part of the exchange between Faber College and Alice. The transcript itself won't be put on the blockchain because that would be personally identifying information. So things like schemas and credential definitions can go on the blockchain. Things like pairwise digital identifiers can go on the blockchain because they're just identifiers and they have no personal identifying information. So most of these start with sort of a high-level communications diagram, and then you get a little bit of a workflow data flow diagram here. So here we see that job certificate schema simply being sent to the ledger, and similarly sending the transcript to the ledger would operate in the same way. That's why I was suggesting it'll probably be better for, if you want to work through and run these, you can. The other thing I guess I should highlight in these diagrams is sometimes you want to know, like, what does that credential actually look like? What was actually exchanged? Not just show me the arrows, but what was actually exchanged. And so you can see that on the right of every one of these diagrams. So for every message, every communication, either between the two parties or in terms of what's actually getting written to the ledger, you can see that here. So it's really just the numbers, and we don't really have any numbers that we could pull off in a hurry. But the job application proof request, this looks like it's the, this actually looks like it's a transcript. So we've got last name is Garcia, degree, Bachelor of Science in Marketing, Social Insurance. So this is a filled in transcript. So this is a transcript credential. Here's some schema. I believe this is some schema that's coming up here. Here's a proof. So sometimes we have a credential, we have some information. We want to ask the blockchain to verify this. And so we'll get essentially a proof back about whether that operation, that verification operation succeeded or not. So lots of information, lots of details to get down kind of into the nuts and bolts of how things work. I'm just going to see if there's anything that looks super unique down here. No. So that's the Getting Started guide. Let me just show you the setup guide so that you've seen it at least once. So when you go to the project, the Indie GSG EA project or repository, it's going to look like this. So the main README file here is the setup file. And if we go down to the Windows section, this is going to tell you manually how to go through, create the Indie folder, create the Indie dev folder by cloning the project. You need to do a little bit of setup in Docker to share your C drive and make it available to Docker. And then there's those steps that I talked about where you're actually cloning the repository and you're building the two images. And then you can test it following the steps that are in here. So those are the two main documents. There's the setup guide and the walkthrough. And then this is what you get when you search for Indie GSG EA off of Twitter in terms of the links. If you don't click on the wrong thing. I don't have Translate on. So there's those two documents. There's the Sovereign Architecture Reference Model link, the walkthrough. This is an interesting article on phases of foundational technology development. I've got a couple slides, I think, to finish with that. So the recommendation here is to, a half an hour after this one's over, come to Mike Lauder's session. He's going to take you through Aries. Again, Aries is that new version that supersedes Hyperledger Indie. He's going to talk about an Aries agent, agent-to-agent communication, and he'll have multiple agents running. Standards have been created for this communication, so what we see happening in the community now is a lot of independent agents are being developed in different languages. The group, the Evernym and Sovereign teams are hosting code camps in Salt Lake where people are bringing their code and they're making sure that they've got interoperability, across all of these different agents. And what you're going to see here is a couple of those agents as part of Mike's talk. He's going to talk more specifically about verified credentials. In the Python script, we are talking about credentials. We're filling in credentials. There's schema for credentials, but we're not using any SDK support, where it's all kind of hand-wired in the Python script, and so Mike's going to be talking more specifically about that. So just a final note, we're really, in my mind, in the early market in relation to the use and application of blockchain technology, and especially as that relates to digital identity. So there's a number of leading specifications, implementations, governance framework, Sovereign that Phil was talking about this morning. But I don't believe we're actually that close to anything becoming the industry standard. And that's not that what other people are doing isn't good, it's just that they're too new. There's specifications that have just advanced into the W3C working group in the last few weeks. They are being written right up until the day that they were submitted. So I'm an early adopter. I'm going head first into all this stuff, but as a general guidance and I guess a few years of experience, there is a technology adoption curve that does take time for things to mature, and just it's going to take a while for some of these things to become pervasive. Here's an example that I like to use. People talk about the asymptotic adoption of digital identity and blockchain, and this is from a report that a friend of mine, Daryl O'Donnell, wrote. And so I took Daryl's chart and I put the Gartner hype curve on it. And if you're familiar with the hype curve talks about the peak of inflated expectations, the trough of disillusionment, the slope of enlightenment, and then the plateau of productivity. And Gartner has shown over and over again that this is the common path for a lot of new technologies, particularly from an enterprise customer perspective. Daryl kind of giggled when, you know, the trajectory of his curve like perfectly matched here. I mean, I didn't do anything special. This is like Windows Paint. But it's just a little bit of a sobering thought. And so, you know, in terms of any technology adoption, you have to start with, you know, early adopters who are going to be accepting and you know, willing to take the risks. Should an entire country or an entire nation bet on whatever? At this point, I'm not so sure. I think a lot of the like really good examples, the really good environments for proving this out is a lot of the work that's being done with refugees and refugee camps. I mean, it's just like, I don't want to diminish what's happening there, but it's a perfect laboratory because you have people with no information, no credentials, no identification. And you can start in giving them a card with a digital identity. Maybe it's got some retina, some biometrics on it. And then as they are able to find or produce, or family members are able to deliver credentials, you know, you can attach those credentials to their identity, and you know, they can build it up. So there's lots of good places, small populations where I think you should be using a digital identity and becoming comfortable with it, but it's still pretty new. I'm giving a talk tomorrow, the second keynote talk, talking about this idea of the trusted digital web and kind of the future of the internet and whatnot. I've given you guys a little bit of a hint what that's about, but I hope you come to that talk tomorrow. Any final questions?
Can you hear me? I have been running the demo through the Docker file after running the Python script that you talked about. Now all the setup is being completed, but at least I would like to see where the ledger is. I mean, in the images, in the container file. How can we observe the JSON?
That's a more detailed question. I'll come over and we'll look at it.
Yeah, sure.
Okay, afterwards. Any other questions?
Thank you for the presentation.
When you run the Python script, it does just spew stuff like into the PowerShell console. You could redirect it. I usually just do a great big copy and paste. That's how I saved it out. Yeah.
In the last presentation, probably Professor David, he said that we can think verify credential concept without the blockchain. I mean, verifiable credentials can be implemented without using blockchain. So, I mean, they are not.
Who said it? Did Phil say that?
Yeah. No, Phil or David. I'm not sure about the name. I mean, it's meaningful. I have the same question about verifier credentials and the DID's relationship. I mean, do we have to implement the DID solution while we're using, for example, verifiable credentials solution in our use cases?
So if you implement, the question is, just to repeat, is if you implement or use verified credentials, do you also have to implement DIDs? So,
because I was wondering who's managing the DIDs, because there are lots of DIDs. The user, the holder manages the DIDs, or yeah. So there are lots of DIDs. So who's responsible from the, for example, general management of the DIDs, or is there any?
Okay, let me see if I'm understanding. So the one point I want to make is Like people think, and I've tried to emphasize that a bit, like one person's going to have a did, maybe a corporation's going to have a did, a corporation is going to have a did. A big corporation is going to have billions of dids. They're going to have dids for everything that goes on in that company. There's going to be millions of dids that are part of some sort of transaction every day or every hour in a big company. So don't be afraid of having lots of dids. Specifically around verifiable credentials, and I don't remember the comment from before, but in a perfectly did world, or at Microsoft we used to say in the fullness of time, everything is going to be identified by a did. Like even today, like I don't believe it's optional, but a verified credential has to have a did in it just to identify that credential, just to name that credential. Another part of the question is, does that credential also have to have the did of the subject that it applies to? And that's not necessarily. It kind of depends on your use cases. There's people that would say, if you can get by making that credential anonymous, by not having it tied to a subject, then that's probably a good thing. But if you believe that credentials, so there's verifiable credentials that have sensitive information and personal information, that's one thing. I'm becoming a fan or a believer that credentials will be used for all kinds of data. And dids will be used for all kinds of data. Like why can't you have did : color : red, and it always returns the RGB of a color red. And then maybe there's a parameter so that you can get the word red back in Turkish or French or Spanish. So I believe in the universal application of did technology and also the universal application of credentials for representing any entity or object. Now, not all of those credentials will be verifiable. Not all of them will have a proof on the blockchain, but it'd be nice to have a unified way of naming data. And essentially, I'm giving away my talk a little bit tomorrow, but building a new internet based on dids as the primary identifier for pages and images and numbers and XML, whatever. Does it? Okay, we can talk more about afterwards. Okay. Any other questions? Yeah.
At the beginning of the presentation, we said a set of claims are credentials.
You said a
set of claims are credentials, and set of credentials are profile for the dids. In the example, the Alice example, after that, the workflow goes like actors, business roles, processes, then the credentials. What are the claims for that workflow?
I'm not sure I'm following that. We'll talk afterwards.
Right.
Any other questions? Sorry, I'm having a few problems.
Okay.
Yeah.
So I believe a did is being controlled by the control of the private key. Am I correct?
What is control?
Did. A did has a public key and a private key. And it's being controlled by the ownership of the private key.
So this was the favorite problem I had about this time last year, because people in the community who'd been working for DIDS a long time used to say that DIDS had public keys and DIDS have, and I said, well, how can a character string have a public key? So I'm just playing with your question a little bit. So DIDS is digital identifier, or sometimes decentralized identifier. And so that identifier is just a string of characters. So it doesn't have a public key, and we're going to probably find a different way of asking your question. So the DID doesn't have a public key or private key. It's just an identifier. It's just a string of characters. But associated with DID, associated with the identifier, is a DID document. And that did document has information about the subject. And the connection between the subject and the did document is that identifier. So it's actually the subject that has a public and private key. And the public key is stored in the did document, but technically the did itself does not.
So the subject is the ID owner, and subject has only one public and private key pair then?
No. A subject, remember a subject can have multiple personas, and hence multiple digital representations, multiple digital subjects, and so multiple dids. So it will be commonplace for a single entity, a single person, to have hundreds or thousands of dids. Like if you're in a conversation with all the people around you, it might be one group conversation, and you might have one did for that conversation, but it might be different from your personal did. Or you might have one-on-one conversations with everybody around you, and you might have 8 or 10 dids for those conversations. So ask your question again. A person or their persona is going to have multiple dids depending on the relationships and the conversations it's trying to manage.
So then each persona has a private key.
And each one will have a key.
Okay, so the control of the did is being made by the control of the private key.
Well, the controller, yeah, we talk about the controller of the subject, yes.
Yes.
And in the case where, so now we're getting into, this is where you need to go to the sovereign glossary. So if you're able to make decisions on your behalf, make legal decisions on your behalf, then you don't have a controller because you are the controller. If your cell phone has a did, it's going to have something called a thing controller. That's a controller that can control that cell phone, but it has to have an entity that controls it. So you would be the controlling entity, the controlling did for the thing controller, and the thing controller would have authority over your phone. So that's for inanimate objects, for business documents, for things, they're going to have thing controllers, and you can Google thing controller.
Thank you.
Question?
It might be ridiculous, but I just got a point that there are two systems that they're messaging with each other, right? Yeah. Are they sending these messages with a plain text mode or encrypted?
Okay, so generally when we're talking about communications, there's different layers there.
Yeah.
Right? So, for example, if they're using HTTP to communicate with each other, they're probably going to use HTTPS, and so that channel will be encrypted.
So it's depending on the channel.
On the channel, yeah.
Yeah.
Yeah, I'm not aware of anything explicit related to the encryption of credentials themselves or did documents. But we could ask Mike that in the next session too.
Okay, thank you.
If you don't mind, please, can you summarize what is this session all about? Because you are a very technical guy, I guess. So you said that, I guess, and this is very related to next generation of internet. So can you please recap what was it all about? Because I missed it.
Oh, okay.
I'm also a technical guy, so
okay.
I would like to hear you.
Okay, so the fellow asked for just a recap on sort of the goals that we were talking about. So think of it as a primer, a first lesson in understanding subjects, digital identifiers, digital identities, and the very basics about credentials. And to show a Python example of how of a particular implementation of the Alice buys a car user scenario. And we had 4 or 5 use cases there. And I showed how we would develop those use cases and ultimately create a digital identity blockchain-based credential type solution, even if it was just a Python script. And then I showed where you could find those artifacts and what those flows looked like, what the messages looked like.
How do you think that this will change the internet, or how we can leverage this?
I'll talk about that tomorrow in my keynote presentation. Okay. Any other questions? If people have one-on-one questions, questions I wasn't able to answer well before, come on up to the front. And thank you everybody for coming. It's